For this next part, we're going to need a graphing calculator. So if you don't have one, make sure you use, well, if you don't have one on you, make sure you grab one or use the one that's built into your Chromebook that you can access in that bottom bar. But we're going to use real world data to help us make quadratic functions. We're going to use that to help us make predictions. We're going to use this thing we're going to call a quadratic regression method to do that. And again, we're going to need a calculator for it. So here's a table that shows the cost of a circular plastic wading pool on the pool, or based on the pool's diameter. So the bigger the pool, the more expensive it gets. We're asked to find the quadratic model for the cost given its diameter. Use the model to estimate the cost of the pool with an 8-foot diameter. So I'm going to switch the screen here a little bit. I'm going to shrink this down so that way you can see the graphing calculator on here. So I need to shrink that a little bit more, I suppose. Actually, this should work, as long as I don't move the calculator too much. All right, so what we're going to do on our graphing calculator, we're going to turn it on first. Now, in the middle of the top or the second row, we're going to press the button Stat. This is where we're going to enter this information. So we're going to go to Stat, select Edit for enter, or select Edit, and this is where we're going to enter in our information. So I'm going to type in our diameters in the first column. So we have 4, 5, 6, 7, and hit Enter after you finish every one of those. And now we're going to go over to L2, and we're going to type in those values. We got 19.95, so we're entering in our prices, 20.25, and 25.00. It'll just type in 25 if you type in the 0.00, and then 34.95. Now, first thing I want to show you is how to get this on your graph on the calculator. So if you go to y equals, the first thing you're going to want to do is I would clear out anything that's in there. Now we want to turn on plot 1. So if you press up and then hit enter, it'll turn on plot 1. Now that's going to graph all those points. So it's going to do the point at 4, 19.95, 5, 20.25, 6, 26, 25, and 7, 34.95. So if I press graph, it should graph those points, but, well, we can't see those because our y values need to go much, much higher. So we're going to go, we need to make sure we see 4, 19.95. I can see 4 over here, but it's only going to go up to 410. So let's go to our window. And the x values, those are our diameters. Let's just leave it, let's start with a diameter of 0. You can't have a pool diameter that's less than 0. Now for our y maximum, we need to go higher. Right now the highest value we see is 34.95, which is close to 35. Just to go overkill, I'm going to go to 50. So going from x equals 0 to 10, and then I guess I could change my y min to 0 as well, because you're not going to have a price less than 0. Let's take a look at this, what this graph looks like now. So there's our 4 points. Now we're going to use the calculator to come up with a quadratic function for this. So what we're going to do is we're going to go back to that Stat button, and instead of going to Edit, we're going to go to the right to the Calc menu, and we're going to scroll down to option number 5. Option number 5, it says Quad Reg. That stands for Quadratic Regression. So we're going to hit that. Now, a lot of times, if you're using a TI-84, it'll show with this list. Don't change anything about this list. What we're going to do is we're going to leave, this is saying our x values, which are where our diameters are in L1, our y values are in L2. We don't need to change that. Don't worry about these two. I can show you how to use those later. We're just going to go down to Calculate. So we're going to select Calculate, and there we have it. Now I'm actually going to do one more thing, because if you look in our notes, it shows us all this information. It shows us the exact same values here, but we're missing an r squared. That r squared is not super important right now, but it's going to come in handy later. So to turn on the r squared, I want you to press the mode button and then go all the way to the bottom. So you can either scroll down a bit, or if you just press up, it'll automatically jump to the bottom. We want to make sure Stat Diagnostics is turned on. So go to Stat Diagnostics, go to the right, highlight on, hit enter. So I'm going to go back to that, what we just did, Stat, Calc, option number 5 for Quad Reg. Again, everything there is probably good to go, so we're going to go down to Calculate. And if you're using an 883, it'll just say Quad Reg, you just hit enter. You're good to go. So Calculate, there we have it. Now it matches exactly what we have on the screen. Now we're going to use this to kind of translate it into a function. The function, it says Quad Reg equal, or it's got y equals ax squared plus bx plus c. We just got to fill in the a, the b, the c. So the a value we're going to say is let's just round it to 2 decimal places right now, 2.41. If you want to do all the decimal places, because it's actually not too bad, 2.4125, and it'll be times x squared, minus, because it's negative, minus 21.5625 times x, and then our last value plus 67.6375. Now, if we take this function, go back into our calculator, go back to y equals, and if we type that in, it should match up with our graph pretty nicely. So if we go 2.4125 x squared minus 21.5625 x plus 67.6375, and if we graph that, it should go pretty much through those coordinates, and it's pretty darn good. Now, one thing, this is something that's going to become more important once we get to Unit 3, that r squared value. The r squared value we call the regression coefficient. The closer that r squared is to 1, the better. Now, this one, 0.999, that's really close to 1, which means this is a really good model. This almost perfectly predicts what we're looking for. Now, the last thing it asks for, that's the function for the quadratic model. The last thing that it asks for is, what about when it's got a diameter of 8 feet? So essentially that's when x equals 8. And again, you can see on here, we'll use the table, second graph to get to our table. And if we just scroll down to x equals 8, it'll automatically plug it in for us and gives us our value. Now you could also just use that previous function, this one down here, and plug in x equals 8, or you can use the table. Either one will work. Regardless of which way you do it, you'll see on the graph it says 49.538. So let's translate that back. So a pool with a diameter of 8 feet would cost, and the y value is our cost, we're going to say 49, and then since we're talking money, let's just go 2 decimal places, 49.54, and since we're talking money, dollars. So it costs nearly $50 for an 8-foot diameter pool.